Right, so last time out. Now, SP's been trying to get the spaceship death routine a bit more interactive, I suppose. Dramatic, probably a better word. Dramatic. So I thought we could have a look at it. I haven't seen his code. I haven't looked at it. But I'll show the video he's doing, yeah? What he's done. But let's see if we can figure it out and get the maths behind it. Then hopefully might be able to do something with it. So basically, oh, we've got sound, haven't we? Let me turn that off. Right. That bit there. Let's turn off the sound. Let's. Where's the activate? Because it's the activate that does it, isn't it? There we go. Let's turn that off. Alright, okay. I think I reused that though, didn't I? For something else. Right, so death. You see the go away, yeah? So it goes away. So what SP was trying to do, and I'll show you the video. Where are we? So this was was that the first attempt? This one? Right, let's go back here. Core, your machine just off. Go really quick. Hey Nicomo. So this is SP's first attempt at trying to make the debris rotate. Here we go. And then the second attempt. Right, let's go back to the beginning. Right, here we go. Right. So I can understand trying to make the debris rotate, yeah? So it's just a case of working out the maths, right? Because we've got the basic concept of it disappearing, right? Ship. Where's ship player? Was it in here? I can't remember. Line handles most of it. Let's have a look. Yeah, that's the drift velocity, yeah? So, now, the way Right. The way let's get this open. Right. Did I have a second page? I can't remember if I had a second page. Right. Duplicate. Here we go. Page 2. So let's get rid of all this lot. Except for you. So, we're trying to work out the angle. So it's going to work. It's going to work for everything. Yeah. So we'll get rid of all this lot, because all we're going to be bothered about is a line. All we're going to be bothered about is a line. Right, let's get rid of all this lot. So, this is our velocity. This is the velocity of the lines travelling, yeah? And this is our angle away from the centre of the ship, yeah? The angle away from the centre of the ship, which is that. Now that is a right angle to that at the moment, and I think SP's put a bit of randomization in it. I think. Did you randomize the angle? Yes. So we've got an angle, yeah, away from the ship, right? So the first thing. There's two ways of looking at this, yeah. First things first. Right, let's stick a circle on there. Right. So the first question you need to ask yourself is, where is your pivot point around on the line, right? So where would your pivot point be? Would it be there? Would it be there? Or would you have it smack in the centre? Yeah. Now the pivot point basically means that you can have it rotating along the line. Yeah. You could have it rotating anywhere along the line. So we could have it. Whoops. Let's grab it properly. Could have it pivoting there. You could have it pivoting there, so the short end would be spinning round, and then the big one would be having a big arc, yeah? Yes, well this is what I was thinking, Nakomo. Whoops. This is what I was thinking, that we could randomly put the pivot point along this line, yeah? Along the line. So, what we need to do is we need to work out our line. Right, let's do this. Right, let's just move that out of the way. And we will just basically do this. Right, so the longer the line, the faster it is, yeah? The longer the line, the faster it is. That's what the line is. So this is going forward twice as fast as it would be going away, yeah? Yes, I was thinking that as well, Gary. So what we need to do is we need to pick a random point along there, yeah? So the way to do it is first things first is we've got to figure out where we are, yeah? We've got to figure out where we are. So if I do that, that'll do. And do that again. This time we are going this way. Right, let's colour these lines so we don't get confused. Well, I'm not sure you can see that green. Let's pick a. We'll pick that green there. There you go. You can see that now. Right. So we have to work out the distance between our 2 points. So SP and I were talking about this over at weekend, I think it was. Right? And it's really easy to work out the distance, yeah? Because should be able to just type text. There we go. So this is x1, y1. And this is x2, y2. So if we call this delta x and delta y, so we can work out how long that line is, yeah? We don't need to work it out. We don't need to know how long it is. We just need to pick a point along it, yeah? So delta x is equal to x1 minus x2, and delta y is equal to the same thing, so we know the deltas between the 2 points. Then all we need to do is we just need to randomize the x and y, because that will give us 2 points that then we can do. So we could say, right, okay, let's pick a point. We'll use that there. We'll pick a point there. And on the x, we will pick a point, say there. Oops, undo. Yeah. So we now know where that point is. So if we draw a line, get in the middle. There we go. If we draw a line, we should know where that point is, so that's not going to be... That's not going to work like that, is it? No. John, you need to think a bit better. No. No, 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 no. Oh, come on. Don't do that to me. Right, the point that we're going to pick is a percentage of the line, yeah? So I was thinking it was 2%, but it's not, it's the 1. So if you've got a line, we're going to pick a number between 25% and 75%. And what that equates to is, so if we say 75%, that's going to be, that is going to be round about here for the Y. Oh, drawing lines, go away. It's going to be around there, but 75% on the x-axis is around here. So that means would be our pivot point's going to be around about there. I think that's about 75%, somewhere there. 50% will be there, 25% will be there. But it's 25% from the relative point, yeah? So if we say that this is our relative point, 25% down and 25% across will give us our point there. Then we can rotate round that, yeah? We know what the distance is relative to the X and Y because we've already worked out what the relative X and Y lines are. We've worked out the relative X and Y lines are. So for this part of it, yeah, we'd use the Y differential that would give us the radius that we're going to rotate round, and the X would be the other line, this part, this number.
Hello, John here. Thank you for following. Hope you enjoy the stream.
Hey, my follow stills work. Oh, and it's doing it up there as well. Get in there, John. Ha! Get in there. Welcome. Chaos K. Is it Chaos? Welcome. Welcome. So once you've once you've worked out where your point are, so you have to, let's see, that, right, so we have to work out our radiuses, yeah? So we'll have two radiuses, one from there to there, and one from there to there, roughly, yeah. So there are two radiuses. Now you can work that out just by doing, so this one, this radius 2 is equal to Pythagoras. So it's equal to y1 plus delta y squared. Oh, I can't do squared on this, can I? Where's that symbol gone? Where are you? There. Squared plus delta x no. Let's get this right. That's delta y, that's delta x. We're not using those. So we need to call this point here. We need to call that something. What we're going to call that? What we're going to call that? There we go. We'll call it x width 3, y 3. So R2 is this radius, right? So Pythagoras is the square root of the two sides squared. So here, so it's the distance. It's this delta y minus, no it's not. This is y3 minus y2 squared plus x3 minus x2 squared. And then square rooted. What's the symbol for square root? Oh, have we got that here? Yeah, we'll just do that. So that's R2, and then R1, which is this line here, which is the radius, is y1 plus y3. No, y3 minus y1 squared, and x3, and it's the same, x3 minus x1. Is that right? No, that's wrong. That's y2 minus 3, x2 minus 3. Oh, is that right? Well, I never knew that. Never knew that. So this radius is the difference between y2 and y3, and the difference between x2 and x3. So y2 and y3, x2 and x3. So that's the radius there, and then the radius of this is the difference between y3 and y1 and x3 and x1 squared. So we get the two radiuses, yeah? Then it's just a case of saying, okay, working out our new XY points based around that as being the centre. Well, not the centre, the pivot point. which is the same as doing the rotation of the ship. It's just the pivot points directly in the middle of the ship, yeah? So we do the the cosine and the sine of R1 and R2 around the points. And we just make sure that they're opposite. Because this one, let's just say our angle of rotation is going to be that way, yeah? Our angle of rotation is going to be that way. That means our angle of rotation on this one is going to be that way. Oops. It's going to be that way. So the 2 points need to have opposite angles. So basically, whatever we set the first angle to be, it needs to be 108. So if we set it to 0, let's say the angle 0, we need to set the angle to 180. So 0 plus 180. So if it's 10, then it's got to be 190. Yeah. So it's going to be the angle plus. So this, if this is alpha, the angle alpha, then this needs to be alpha plus 180 for the direction, for the angle. And then what you do for each pass through, then you're increasing alpha by a set value. Yeah, you already know where your pivot point is. Yeah. The next time you do the rotation, you've still got to work out your deltas, because you need to work out where 25% is. Well, no, because you'd already worked it out. You've got your pivot point. You've just got to work out we've got the radius because we've worked it out. We only have to work out the radius once. Yeah, we only have to work out the radius once. Does everybody understand that? Does everybody understand what we're trying to do here? And by the way, we're still migrating at the angle while we're rotating around the pivot. Yeah. So we're going to be rotating around the pivot, but it's still going to be moving. Well, let's see if we can code it. Let's see if we can code it. We are trying. Davros, welcome. We are trying to make our explosions a little bit more interesting. So basically what we're doing is we're trying to, let me run it. iteration, and it sort of rotates. Yeah. Well, we're gonna work it out. Spinning debris, yeah. So our ship here, when we die, at the moment we're just pushing away. You know, we're just pushing away, but we want it rotating. Want it rotating. So I suppose we can do it in the line. I suppose we can do it in there. Because now we're not going to... Right, okay. So we're not, when we're doing this here, we're not going to apply it to the endpoints, right? Here we go. You alright, buddy? Aston! Oh, he's not having a sneezing fit. He just started to sneeze. Oh, we're not getting into that sort of complexity. We're just trying to understand the maths. Just trying to understand the maths. So at the moment we've got it exploding away. So we've got explosion velocity and takes in consideration also the velocity of the ship. But what we want to do now is to add a rotation factor to the line. But not in a specific point. We're going to randomize the point as well, but we'll we'll do it in the center first because we don't. Oh, he's still sneezing. Aston. Oh, he could have stopped. He could have stopped. Now we've got the rotation of the asteroids in. We've got the rotation of the asteroids fine. We're just trying to add the rotation to a line, but we're not centering it. So, I mean, we could have put rotation. Well, this is just to give people an idea. If they want to, alter it, by all means, by all means. Right. So this is all going to change. Well, this bit anyway. This is all going to change. So we've got set drift direction, which is fine. So we need to create another function to set rotation. And then we just work out yes, mate, that's what I was about to do. So we're going to set rotation. So now, do we pass in rotation? Do we pass in our pivot point? Just wondering. Or do we get it doing it in here? Let's add some... I mean, we've got X and Y diff, but they are used down here, aren't they? They are used there. What's X and Y diff used for? Oh, here. Right. Yeah, point is the center point. Point is the center point. In the line, it's x1. x1, y1. Right. So, x delta I'm sure I called it that. Oh, delta x. Now, delta x is basically this here. Right, so we've got our delta x and delta y. Point is the base class of most of the objects in the game, yeah. You got to remember, Davros, that I'm trying to teach people the concepts of object orientation without going too overboard, because some of the guys, it's all new this is, so that they're learning, yeah. So I understand what you're saying, and if I was professionally doing it, I would be doing what you're saying. I would be doing what you're saying, but right. So we've worked out that. So are we we're randomizing the midpoint, yeah. So our pivot point. So that's x3. Yeah. In fact, we'll call it pivot. We'll call it pivot. Y and X pivot. So that's where we're going to be pivoting. That's where we're going to be pivoting around the line, yeah? So, let's see. Float. No. Int. Ooh, random. How do we do random again? It's that, isn't it? Yeah. So, oh, is that how you spell differential? No, that's how you spell it. Right, so thank you. Hello, Fubit. Welcome. Right, so we said that we're going to have a pivot point between 25% and 75%, which means that we've got a 50% range. So we're going to create a random number between 0 and 49, yeah? And then we're going to add 25 to it. So that will give us 25 to 74? Yeah. Yeah. So that gives us our percentage point, yeah? And then I'm going to convert that to a float. And then we're going to divide the whole thing by 100 to give us our percentage value. So, how are we going to work out the points now? Has he gone back to bed? Yes, but now I've put 100.0. Doesn't that divide it by 100 as a float? Or are you saying that the integer divided by 100... That'll fix it. Okay, I'm learning. I'm learning. I'm learning. I'm learning. I don't have to worry about this in C#. Right, now let's work this out. So we're saying we start at x1 and it's percentage from x1, y1 down. So x pivot is going to equal x point plus delta x times by pivot percentage. Yeah, that should do it. That should give us our pivot now. Yeah, that should give us our pivot point. Something's bugging me. So if our delta is minus 60 times by 0.5. Ooh, that's annoying. That'll do it. Right, let me just explain what I was doing there, right? Our pivot, our delta could be a negative number, right? Because if x1, y1 and x2, y2 are the wrong other way around. So if our x point and y point are there and our end points are there, we'll end up with a positive delta, yeah? Because the x point would be say 10, 10. The end point could be 100, 100. So the delta is 90, 90. But if you do it the other way round, where your end point is at 10, 10, and your point is at 100, 100, then you'll end up with minus 90. Yeah? So you'll end up with minus 90. Yeah? Because it'll be 10 minus 100, which is minus 90. But when you multiply a negative number, so 60 negative times by, let's say we'd have the center point in the middle, so 0.5. Oh. Well, what did I do wrong then? Oh, I must have put it in wrong. 60 negative times by 0.5. Why did I do that? Oh well. Yeah, whatever. I must have typed in the number wrong. So I'll put it back round. BODMAS, yeah. I'll put it back. So what I was thinking was that if our midpoint math test, yeah. So if our midpoint, so if it's all right thinking of the obvious, but let's swap it over. So our y point is going to be 100. So plus minus 45. Will be 55. That works. That works. Right, I'm happy with that. Now we need another one here. What? Oh, I was just thinking about it. Rotation, spin. No, spin is velocity. Rotate. Spin angle. That's the angle that we're currently at on the spin. That's the angle. So we need to work out now our angle, our starting angle. Yeah, we need to work out our starting angle. So if the line's from there to there, we need to work out what that angle is. Now, we've already done this. We've done this in UFO, right? Because here, we worked out the angle to us, yeah? So we can do that here. So, let's go back. Spin angle. Is that, and it's in our case it's delta y delta x. That's our spin angle. So now we've worked out from the delta, the two deltas, what our angle is. Yeah. Now we've worked out the angle, we've got our midpoint, we need to work out the radius of the two radii. So, so now we need to work out what the length is of the line that's left over, and we worked it out to be, where's my diagram? Right, so radius 1 is equal to square root of y pivot minus y1, so y endpoint, no, y point squared. Now, I was told off so I'm going to do this. Right, is that going to do it? Y pivot, which is low, minus that one, squared, plus the X pivot. Right. So radius 2 is right. That should work out our two radii. And that's not going to work. I've got a sneaky suspicion I've got this in the wrong place. No. We only work it out the once. Once we've worked out the radius, that's it. Right, okay. Don't need that. So that's everything set up. So what are we passing in? We're not passing in anything, are we? We don't need to because we're setting everything up here. Right, I'm going to fix this because I want to just make sure that our calculations are correct. So I'm going to fix this. So I'm going to fix it to 50 just for testing purposes. Because I want to make sure that we're pivoting right. Yeah. Have I missed a semicolon? 83 and 84. Oh, sorry mate. I didn't see that. Right. So now we've got the necessary values. We now can affect our x point and end point based on here. Now we are no longer going to be oh, that's a good question. That's a good one. Yeah, I know we need all this, but we're no longer affecting the x point and the point and end point. We are adding the velocity to the midpoint. The midpoint. That is our location now. Our pivot point. That's the one that's going to add is going to have the velocity affecting it. So what I was just thinking, we're going to have to go through set rotation anyway. What we can do is this. If we do that, we know that oh, we can't. That's only in here, isn't it? Ah! No. We can do this. Oh, we can't because we could have an X. We could have a 0. Okay. There we go. Right. Hit the wrong key. Right, now we just need to work out our... That will now be pivot. So we apply the velocity to the pivot point and not the end points. Yeah. So now we just need to work out these two and these two. Right. So X so that is going to be a radius 1. And that is going to be, what did we call it? Spin angle. Have we got one too many brackets? Band spinning kids, welcome. Right, so, and then we'll do the same thing here, but the end point is radius 2. Now, something's telling me it's wrong. Oh, night FaiRLane. See you later. I think that's right now. Hang on, let's just check. I think that's right. No, Gary. Oh, I'm losing people left, right and centre. Maths must be too much. Right. That should be it. Now we're not increasing the angle of spin. Okay, spin rate equals something divided by FPS. So what should our spin rate be? Five degrees a second. Right, and we'll, for just testing purposes, we'll fix it. We'll fix it to 5 degrees. Right, spin rate. So when we've worked out our angle, we need to update the spin angle. Right then. Right, let's do this. So where is it? Is it in death? We got a player death where we set up all the lines. Okay. Oh, so it's not in player then. Okay, so it must be in the main. Is it in player? Oh, here we go. Oops, wrong one, wrong view. Yeah, he's sneezing again. It's not been as bad as it has been. It seems to be alright. Right. This, so here we need to do here, don't we? Right, let's see if it works. Let's see if my first attempt is any better than SP's. Ooh, didn't like that at all. I didn't take all the parameters out of the set drift. They're all there. No, I copied the routine, mate, and that's why I took the parameter list out, because I copied the routine. So all our lines should be spinning around the centre, yeah? All our lines should be spinning around the centre. Well, they're definitely spinning, look. Oh dear. Welcome to your world. I have sneaky suspicion I think I've got my maths wrong. I think it's to do with that, to be honest. One, two, three, 4 lines. Right. Let's try. I can't work. I need more data. I need more data, boy. A missing return. Yeah. I've sneaky suspicion that Y is plus. I have a sneaky suspicion that's plus. Minus, sorry. Because we're right smack in the middle of the screen, so everything should be right in the middle of the screen, all the chords. That still doesn't look right. That still doesn't look right. Right, let's add a bit more debugging in here. So, if I do that, will it just give me a gap, yeah? A line gap, yeah? Let's see. No. Doesn't like that. Why are you not allowing that? How can I do a how can I do a line? Why is that not allowed? Why is not liking that? Stupid. All right, let's do that. Whoa! How to blow up everything. Okay, what doesn't... No? Have I missed one? Set rotation. Huh? I'll look at that one, UFO. So we should get the deltas. So the deltas shouldn't be that big. So the deltas shouldn't be that big. 14 and minus 40. That looks about right. That looks about right. So the delta's right. So why is this wrong then? Right, so the deltas look okay. Oh, is it? Oh, yes, it is. Oh, rats, well spotted. Well spotted. That's a definite 10-pointer there. Well spotted. Well spotted. Right. Oh dear. Oh, he's up. Hey buddy. Gary gave you some bits. You want a treat? There you go. Come on, over there. Behind you. Behind you. It's behind you. Go on, your nose will pick it up. Your nose will pick it up. You can smell it. You can smell it. There you go. You got it. Right. Right, let's do this again. I want to look at the numbers. I am now wondering if our angle calculation's wrong. Right, so that's our delta. That's our X point and Y point. That's our pivot point, which should be smack in the middle. Oh, it is! Oh no! How? Oh, channel points. Yeah, I know. I need to do something about that. I gotta find some games so you can gamble away on. I mean, all the gamble stuff's there. Right. So the pivot point's right. So it's working out the pivot point right. So that's fine. So now we need to work out our angle. So I'm happy that all that is working. I'm happy that all that's working. So what I need to now know is what's our angle? What's the angle that it works out? And what's our spin rate? Because I think that's a bit low as well. Right. Let's run this again. Are you hunting for more biscuits, mate? You've only had one set of bits, mate. You're not having anything else. Right.
Oh my god, more bits?
Oh.
Thank you very much. You guys really spoil me.
SP, come on. There you go, buddy. Behind you. Go that way. You're as blind as a bat. That way. Keep going. Keep going. You'll smell it. You'll smell it. There you go. You found it. Thank you, SP, for the bits, mate. Thank you very much. Right then. Let's see. What's our... Right. Right, okay. That's in radians. I think that's in radians. Yep, that's in radians. Okay. If we're working in radians, maybe I should work in radians all the time. So let's do that. So it's 5 degrees by the frames per second. So that's going to give us our radian value. That's our radian value. So when we do our calculations here, we don't need to do this get radians. that's probably why it was flat, because I was treating it as degrees. Right then. What? What? You licking your lips, mate? Alright, I'll give you one more. I'll give you one more. That's it. Go fine. Go fine. Right. Forgot where I was. Oh, we were starting it again, weren't we? You'll find it. His nose kicking in. Problem is, he's blind, so... Oh, there he is. He's got him. He's got it. Right, here we go. Let's see. Oh, we got an asteroid coming at us. Let's get out of the way. Right, here we go. Right, so the rotation wasn't right. Why was the rotation not right? Five degrees a second is not a lot, is it? Let's hoof it up. Mate, don't get greedy.
Oh my god, more bits? Thank you very much. You guys really
Oh, Nico Mo. Hey, Nico's chasing the cookie. There you go, boy. There you go. Well, this is the thing. We might not have a background, yeah? Just to emphasise Aston. Well, we've got rotation. We've got rotation. I think we need more. Yeah, I was looking at that as well. I thought they'd change, but we'll see.
Oh my god, more bits? Thank you very much. You guys really spoiled me.
They're going to make you fat, mate. They're going to make you fat. They are. Do you want another one? Go on then, over there. You'll find it. You'll find it. Keep your nose in. Thank you very much, Docster. Thank you. Yeah, they're cycling, aren't they? But the problem is the angle's wrong as well. The angle starts off wrong. I think we need to add I think we need to add to the angle. Because the player angle has some 90 degrees. What? Is it? Oh, right, okay. But I'm sure. Don't we initial? Yeah. We initial. Yeah. Oh, why? What? Right, so it's got to be something here, right? So we know that that's okay. Have I screwed up the calculation for the... Where did we put the... Oh, it's an asteroid, wasn't it? Oh no. Laser? Where's the function? Oh, distance between. Was it in laser? Oh, my head hurts. Are you wanting to go out? Are you wanting wee-wees? Hey. Alright guys, let me just let me take him out and I'll be back in a second, alright? I won't be a sec. And we're back. Right. What was I doing? Oh yeah, the test. The object test. I can't remember where we put the object test. Was it in player? There's one in asteroid. I thought in the player. Oh, there it is. So it's definitely minus and minus. Okay, so... Here we go. You alright? You alright? You alright? Okay. Oh, he's off. You off again? You off again? You alright now? Hey? You alright? Oh, God dear. Yeah. 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 You alright now? Yeah? They're huge sneezes. And when he does like 10 or 20 and go... 4 o'clock in the morning he woke me up doing it. Right. That's got to, no. I'm still thinking that that's wrong. You finished? He's off. You finished? Eh? You finished? Oh. Nah, I missed that. Right, so that is definitely not right. We're hoping to have some sort of music in the game. What is wrong? Have I got them the right way round? The square root of the difference times the square root of the difference, square root of the difference. Right. Square root of the difference, square root of the difference. Oh, hang on. Oh, John, you plank. Ugh. Well, one problem is the endpoint has a different angle, doesn't it? which is equal to right, so it's 2 pi radians, I think. I think it's 2 pi radians. Oh. Yeah, it's 2 pi. Right. So we need to add that's the number I'm looking for. If we're in radians already, we just need to add pi. So the second angle needs to be there on the ends. Right, let's see if that solves our varying length lines. Oh, am I missing?
Oi, John, pay attention to chat.
Thank you. You was quick in there, mate. You was quick in there. Typed it. You must have exclamation mark listen in your clipboard. Oh, you typed it. That was impressively quick, mate. Right. There's some rotation going on, isn't there? The lines are changing. They are exploding now from the right place. They are exploding now from the right place. It's just that the lines are changing length. Now, what could be causing that? Lines changing length. Oh. Oh, hang on. It's an ellipse, isn't it? Yeah, it looks like it's in 3 dimensions. I think it's because the Y is big and the X is little, right? So when it rotates, yeah, it's rotating like it's an ellipse. So, but how are we going to do that? How are we going to solve that? It's rotating as an ellipse because the delta between, yeah, it, and so we're working the radius based on the. So one rate. That can't be right. That can't be right. The radius should be still the same for both of them. Find out what the numbers are. They should be the same. The radius should be the same. Radius 1 and radius 2 should be exactly the same because we've put in the pivot point in the middle. And they're not. Oh, let's have a look at the drawing. I don't understand that. They should be the same. Oh, okay. That's wrong. Have I worked this out wrong?
Oh my god, more bits? Thank you very much. You guys really spoil me.
Thank you, Docster. Oh, have I worked this out wrong? Hey, buddy. Want another treat? Want another treat, Docsters? Give you a treat. It's over there. It's over there. I think I've worked this out wrong. Let's imagine that they're just two objects in the sky, yeah? So, let's turn these around. I think I've got me numbers the wrong way round. Oops. Right. So we're doing the difference between y point and y pivot, x point and x pivot, and then Y pivot to endpoint, X pivot to endpoint. I think that's what I was screwing up. Because I'm just looking here. We're testing our point with the You alright, buddy? You alright? I'll get him in. Also, no, they're pluses. Yeah, I am plussing. I am plussing. Right, let's see if we get the same. Yeah, buddy. See if we get the same number now for the X and Y, because we should be slap bang in the middle of it. And we're not. That's why it's changing shape. It's not working it out. The midpoint. It's not working the midpoint out right. No, what am I doing, John? The radius should be the same length. Yeah, buddy. You alright? You want to say hello? Come here. Come here. Come here. Come here. Come on. Say hello to your adoring audience, eh? Say hello. You saying hello? Hey? Say hello. Look, everybody's waving at you. Yeah? You gonna have a sneezing fit on me? Hmm? Alright, don't have to panic. You ready? You ready? There you go. You've got him going now. Go on then, pump the biscuit. You've seen me throw it, go get it. Right, so why are these radiuses not the same? If we're picking the midpoint, why are the radiuses not the same? I wonder if it's to do with that. That's definitely wrong. So I was right to start with. Alright, see you later, Nikomo. See you later. Work at the center point, we rotate. Oh, he's off again. You sniffed up some fluff up your nose, did you? Eh? Did you sniff up some fluff? Right, okay. I'm going to have to think about this. I don't know why the radius is not the same. I don't know why the radius is not the same. Oh, it's got to be something simple. I'm just not seeing it.
Hi, John here. Another subscriber. Stay a while. Stay forever.
Oh, Kylo Dos, thank you for the gift sub. Thank you very much. What's the matter, mate? What's the matter? You've been out, you don't need to go again. What? I'm not giving you any more. No. No, not giving you any more. So, all right, guys. I'm gonna have to think about this. I'll put the code in the Discord server so you can have a look at it and see if you can spot what I've done wrong.
Oh my God, more bits? Thank you very much. You guys really spoil me.
Biscuits for me. Thank you very much, mate. Here, Docsters give you a biscuit. Go hunting for it. You know where it went. That's it. Keep him busy for a bit. Alright, I'll put this in Discord, yeah? Because I don't know, I can't see where I'm going wrong. One thing I will do though is we will do this to find out what the radius is. and then we'll stick it in there and see if the two numbers marry up, because that will be. You'll sniff it out, mate. You'll sniff it out. I can see it from here. Right. $42. Well, that's wrong. If it's 42, 29 plus 21 is not 42. So I am fundamentally getting my centre point wrong. Fundamentally getting my centre point wrong. Right. And that's why I think that's why the lines are... Oh. Alright guys, I'm going to put this in Discord. I'm going to have a look at it off stream as well. And see if you guys can spot something that I don't see. I mean, I should be able to do this, shouldn't I? I should be able to do this, shouldn't I? Oh, it won't do it. It won't do it while I'm on there. Debug. Why isn't it stopped? Debug. Oh, why can't I debug this? Oh, come on. It's there. Why can't I debug this thing? Oh, what have I done? I've blown it up. Yeah, you shouldn't need to. I've blown this up. I don't understand why the debug point isn't working. Are we back on track now? Oh. Oh, it's just not stopping, is it? Can't even debug this thing. Oh, hate C++ with a passion. Alright then guys, I'm gonna call it. I will put this in Discord. You guys can have a look. But this should work. This should work. It works for our collision detection, so it should work. And that's the distance between the two center points. So this should work. I just think it's probably this that's wrong. But then again, that should work. We're doing the deltas. Alright then guys, I'm going to call it. And we'll continue this on Wednesday. I thought it should have been fairly simple, but hey ho. Alright then guys, I will see you on Wednesday, yeah? Alright, take care. Chat to you a bit. I'd like to thank all the Patreons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much.